Lecture 8-2, Volcanic Eruptions. Now, volcanoes don't all erupt the same way, and an eruption just pretty much means when the magma comes to the surface and moves through the openings to become lava. Now, a typical way that a volcano erupts, though, is that we get the magma chamber deep underground. This can be very, very deep underground. It fills up. Now, as the temperature of the rocks go up, the pressure builds. Now, also inside this magma, inside the magma are gases. Those gases can also build up pressure too, and so it's the pressure here that will determine when a volcano erupts, either due to the temperature or to the gases inside of the magma. Now, as the pressure builds up, eventually the pressure becomes strong enough to push the magma out and down the openings. But sometimes this can be blocked. If there's a block in the opening, the pressure is going to have to build up a lot and a lot and a lot. Sometimes, though, it's very easy for the magma to seep out. And so not all volcanoes erupt the same way. We can have very quiet eruptions where we're just looking at lava flowing over the landscape, or we can have very explosive eruptions where there's a ton of gas that builds up, ton of pressure builds up underground, and all of a sudden it just all explodes out at once. Now, again, there are different types of eruption. It's quiet if it has low silica. Now, remember, that depends on the type of rock. It'll flow very easily, and so that will have a low viscosity. We'll talk more about viscosity in a second. It can be explosive if it's high in silica, has a high viscosity. And that's because it's harder to flow and ends up plugging up smaller openings and can lead to very violent eruptions like Mount St. Helens did in 1980. Now, see an example of a quiet eruption. This is Kilauea Volcano in Hawaii. You can see that this is the typical eruption we get from Kilauea. A lot of lava flowing outwards. You can see this is, again, not an explosive eruption. Even though you see the lava bubbling up in that, we don't see any explosions. You don't see the whole volcano erupting out of the side. Instead, the main hazard from this type of eruption is going to be lava flow. And that lava can flow out very, very easily. If that lava has low viscosity, it'll flow very easily. There's less chance for pressure to build up, less chance for violent eruption. However, if we look at an eruption like here, where we see Mount St. Helens. Now, Mount St. Helens in the early 1980s erupted so violently that it blasted off part of the side of the volcano. You can see that right here. You can see the side of the volcano got blasted off. All the trees down here end up getting flattened out by this explosion. The pressure built up because there wasn't just an opening for everything to escape. Instead, the gases and the heat built up over time until it was so much that it escaped violently. You can see this ash cloud is going to be sent upwards, and ash can travel very far distances. If Yellowstone ever erupts, which would be a very violent eruption, ash would actually fall in Iowa. In the case of Mount St. Helens, some very, very fine particles did make it to Iowa, but typically not enough that anybody probably noticed. And so here you can see that this is a very violent eruption from Mount St. Helens as it exploded. It blasted off the side of the mountain, and it pretty much all the trees on one side got flattened down. So the difference in those types of eruptions boils down really to the magma or the lava. Magma is, of course, what we call below the surface. Lava is above the surface. And decay from radioactive materials and pressure from gravity starts magma out as liquid rock. It's what gets that heat, which will start it out liquefy the rock. Now, types of lava will vary depending on their composition and their viscosity. Viscosity is the resistance to flow. Pretty much what that means is if you have high viscosity, it's going to go slowly. Low viscosity flows very quickly. Think about syrup. If you put syrup in the fridge and then try to pour out, that's going to have very, very high viscosity. It's not going to flow very easily. It's going to have a lot of resistance to the molecules kind of moving past each other to flow. But if you take that same syrup, you put it in the microwave, heat it up a bit, and then try to pour it out, it's going to flow very easily because those molecules are now going to be a little more separated. They're going to flow very easily by each other, and so it'll flow very quickly. Now, there are different types of lava then, typically nonviolent. We can look at three main types. This type is called it's cooler, slower moving, rough and jagged, tends to have a higher viscosity, so it's going to flow very slowly. Of course, the red areas are going to be the hotter areas, and then you can see these areas here on top, those are already starting to cool. And because it's flowing very slowly, and it'll keep flowing even as it's cooling, you're going to have very jagged edges here. Volcanologists, scientists who study volcanoes, when they step on lava after it's been solidified, their boots can be torn up, and they may go through like a boot a day. Pahoehoe lava is kind of the opposite. It's very fast-moving, hot lava, has very low viscosity. You'll end up getting like folds and wrinkles. You see here 2 different cases of Pahoehoe lava. It will travel very, very far away from its source, and because it's moving very quickly as it cools, it'll get a much smoother surface on top. You see here, anywhere that's red on the inside, that's going to be where it's still not cooled down. It's a very hot area, but eventually that'll cool down and solidify. And pillow lava is just when we get that kind of like Pahoehoe, but underwater. And when it comes in contact with water, it's going to cool down much more quickly than contact with the air or the ground. And so you're going to end up getting these pillow-shaped pieces of lava forming. And when you look at the Hawaiian Islands, they have a lot of volcanic vents that come out underwater. And so you see a lot of pillow lava forming down there. And those islands are actually constantly growing because of the lava being added to the edges. Now, predicting volcanic eruptions is actually a lot easier than predicting earthquakes, a lot more accurate. First off, we look at the history. How often does it erupt? This will give us a time span, like will it erupt in the next 10 years, 100 years, 1,000 years? Small earthquakes can easily precede an earthquake. They can tell us if there's pressure building up underground. With Yellowstone National Park, we notice that the amount of earthquakes that have happened there have greatly increased over the last decade, which could signal that it's getting ready to erupt, which would be a very devastating event. Slope deformation. An example of, think about your standard volcano shape. If all of a sudden it builds up and you can see kind of where you're getting a side is getting thicker or changing as pressure builds up, that's going to tell you that it's getting ready to erupt. Gas emissions, we can analyze the gases, and that's what some of these scientists are doing here. All of these gases which are escaping out of the volcano can be analyzed, and we look at the composition of those gases. They will tell us if it's getting closer to erupting or not. Then, of course, remote monitoring, putting sensors in the volcano, just detecting different things. We even go and collect the gases. You can actually collect lava as it's closer to, let's see, this is a very solid place out here. You have liquid spot here. They can throw something in here, collect the lava, and then analyze it. And that will tell not only what gases are in it, it'll tell its composition, if it's going to be high viscosity, low viscosity, help us determine type of eruption. But we can get a pretty good idea when volcanoes are going to erupt. That's why we have a lot of seismographs located around volcanic areas, and we monitor those very closely. We look for how often do earthquakes happen. Now, Yellowstone has earthquakes all the time, but it's how often that they happen that's been increasing. In Alaska, we've had some volcanoes that we were able to predict within a couple months, saying it's going to erupt within the next couple months, and then it does erupt. And it was mostly based on seismic activity.